Hello everyone. Today's notes we're going to be talking about rewriting expressions. So a rational exponent, what we want to define first, is when the exponent or power is actually going to be a fraction. And this can be written in two different forms. So the first form we might see is we have a, this is just using any variable, but we have to the mn power. So that is our fractional exponent as we see there. And then what we're going to end up doing is writing it as an actual radical. So we're going to go from our exponential form to our radical form. So n is always going to be the index, and again I will show you this in a second, and a to the m power. So this always goes to here. The higher number, I always think of the higher number is the actual exponent. The other way that you can see this written, we're going to end up seeing that we have a parenthesis around that a, because that exponent m to the n will end up being an exponent for whatever is inside that parenthesis. Then we will rewrite it as still the n will be that to that index. Whatever was in the parenthesis, there might be more things than just the one letter, will all be raised to that exponential power. So if you guys are following along on my guided notes, if not, please go ahead and write that, but you should be following along the guided notes. What I want to show you here is that we're going to be converting between radical form and then to rational exponent or exponential form. So what I like to use is I use I for the word index, because that is what is identified for that value right there. So it's an invisible 2, the index is 2. If there's a little baby 3 or a 4 or a 5, then the index is 3, 4, or 5. Then we have e for our exponent. That's what I'm going to represent that as. So where this I goes, to remember for our fraction, if we have our I here, I'm just going to draw arrows. The I will always, always, always go to the bottom of our fraction. Then our e will always go to the top of our fraction. And vice versa, you guys. So if we are an exponential form, and then it goes the other way. So e will always be on the inside right here for that exponent inside that radical, and then the I will always be our index. So that's where those values will always be represented. So make sure you have your little arrows. They will always, always, always go in that position. Okay, so again in your guide notes we have some examples, and you'll see that you'll have some practice problems as well. So in this case we're going to practice converting exponential expressions from our exponential form to our radical form. So for here we see that we have 4 to the 1/2. Well, remember that 2 is the index, so I'm going to write whatever the radical is. We have an invisible 2 here. We'd normally not write that 2, so I'm going to eliminate it, which if we just have that square root, that means it has an invisible 2. Then we have the 4 to the 1 power. And we don't typically write a 1 with a little invisible thing. That's why I keep asking you guys what's that invisible value there. So we have just the square root of 4. Okay. Hopefully a lot of you guys know that square root of 4 would actually break down to 2. That is a perfect square. Okay, so then now we have 4 to the 1/3. So now my index is actually have that little baby 3 instead of the 2. Let me write that 3 better. So we have 3, and then remember it's going to go as the index, and then we have the 4 to the first power inside. I'm going to stop writing that 1 because you guys should know that 4 to the first power would just be written as 4. This I cannot simplify. I'm going to leave it as is. And I actually already answered our questions. Then we have 4 to the 1/4. That 1/4, that fourth power is going to go for our index, and then we have a 4 to the 1 power. Sorry, I said 4 for the power. 4 is going to be our index. I did write, can we simplify any of these? I actually ended up already simplifying that first one. So yes, we can actually simplify the exponent to the 1/2. So yes, number 1 can simplify to 2. Because it's actually the square root. And then why can't we simplify the 1/3 or the 1/4? And that's because the index, that number right here, tells us we need groups of 3s and we need groups of 4s. So because of the index is a 3 and a 4, is y. We don't have groups of 3 and we don't have groups of 4 with 4 being broken down to 2 and 2. So that's why. All right, moving on. So we're going to convert again from exponential form to radical form, and then we're going to simplify when we actually can. So we're going to go ahead, I'm going to do these 4 examples. You guys will then practice these 4 examples that I will write down for you, and then I will go on to another set of examples. So we're going to go from, we are currently in exponential form because you can see that we have an exponent of that 1/3 in all of these, or just an exponent in all these. So we need to put it in radical form. This radical is going to be a cubed root with that index of 3, and then 7 to the 1 power. We cannot simplify 7. 7 is actually a prime number, 1 times 7. So then now I'm going to move on to the next one. 3, or the cubed root of 7 is my final answer on that one. This one is going to be the cubed root of 27, and that one I can actually break that down. I know that it is 9 times 3, and I know that I could break down that 9 to 3 and 3, which means I'm looking for groups of 3s, and I found one. I actually had 3. I circled everything, so then I can actually simplify that 27 1 to the 3rd power, and it's actually the cubed root of 27, which equals 3. Okay, I'm going to erase a little bit of this so that I can then show you guys, but please don't erase it on your notes. Hopefully you guys have some space that you can find on there. Now, this one's a little bit more difficult. So 12a, the a is the only one that has the exponent. So the 12 is going to stay outside, but that cubed root of a squared is going to stay inside the radical. Again, this little exponent is only with the a, it is not on the 12. So that's how we write this, 12 cubed root a squared. I cannot simplify the a squared inside that radical because there's only 2 of them, and the index is telling me that I need 3. So that is my final answer for that one. Now, this is why the parentheses were so important here, is that I now have the index, sorry, let me back up. So I have 3a to the 1/2 power. We need to make sure that we distribute this exponent of 4 to all the exponents inside the parentheses. Remember, the invisible exponent on that 3 is a 1, so 4 times 1 is 4. So 3 to the 4th power. It's not 3 times 4, that's what I was going to say. And then we have 4 times 1/2. So think of your fraction as this. You're just multiplying by 4. When we make that 4 a fraction, it's just over 1. We multiply straight across. Straight across. Okay? So 1 times 4, so we get a to the 4 over 2. Well, what's 4 divided by 2? We just simplify that. So I have 3 to the 4th power, a squared. And then my final value is I need to multiply this value by itself 4 times. So we have 3 times 3 times 3 times 3, and we end up getting 81a squared. So then that was our final solution for that one, because we were able to distribute that 4, that exponent went to all of them. Okay, and we ended up not having to even go into radical form because we didn't have any fractions. So if there was a fractional exponent, then we would have to, just like how we see on all of these. These are all fractions, and we got all radicals to help us simplify. But when we actually distributed that 4, we ended up not having a fraction left over here, so we were able to just simplify and get our final answer. Okay, so I'm going to write down some of the problems I want you guys to try on your own, and you are going to convert from still exponential form to radical form, just like what we practiced. So the first problem I would like you guys to attempt and see if it could be simplified. We are going to do 5 to the 1/3 power. So go ahead and put that into radical form. I'm just going to write these quickly, you guys, but you guys can pause the video and go ahead and actually complete them. We have 81 to the 1/4. That's a 4. Let's rewrite that better. And then we have 5x to the 1/3. And then we're going to have 1 in parentheses, the 2y to the 1/3. And that's going to be to the 6th power. So again, go ahead and pause the video. If you need to rewind it to go over the examples we just did for the assignment, please do so. Okay, we're going to move on to some of the more examples. So now we see that we actually already have a radical and we need to go to exponential form. So I'm going to end up, we just turn it into our index, but what you want to do is you actually have to simplify when you are in this form first. So I have 3 b's in here, but I'm looking for groups of, I need actually 5 of them to leave the house. So I can't actually simplify in this radical form here first, so I'm just going to write this directly into exponential form. Remember that 5, the index goes on the bottom part of your fraction, and the exponent goes in the numerator of your fraction. So this is just b 3 to the 5th power. Again, this goes here, x is the exponent, and then your index will always go in the bottom there. Here on the cubed root of a squared, I need 3 of them in order to leave the house, so I can't do that again. So my simplified fraction that it just has to stay like that is a 2 over 3, a to the 2/3 power. Here I need the x has to have at least a group of 3. I can't do that. So be careful because that 4 does not have this exponent, but the x does. Remember that the little invisible number over that x is actually a 1. So that's going to be my exponent 1, and then my index is 3. So 4x to the 1/3 is the only thing that, the x is the only thing that actually has that fractional exponent. Now we see the parentheses here. These parentheses mean that we actually are sharing this exponent of 4 and the index of that little invisible 2 for that radical. So what I'm going to do is means that we're actually looking for groups of 2. So I'm going to go ahead, there's 2 different ways to actually simplify this. I told you guys to simplify in the radical first. So this means I have, remember, to the 4th power, to the 4th power, and you multiply those exponents, 4 times 1, 4 times 1. So I have now 3 to the 4th power and x to the 4th power. Okay, let me try and delete this little thing. And then, so 3 to the 4th power and x to the 4th power. We need groups of 2. So if I write out this in an expanded form, I have my 4 3's, then I have 4 x's. My index is telling me I need to circle groups of 2. So when I do that, I see that I actually have everything that's going to go outside. I have 2 groups of 3, and I have 2 groups of x's. Just simplify that 3 squared. We end up getting 9, 3 times 3 is 9, so I have 9x squared. So that is my new simplified value there, 9x squared. So I ended up, my fraction again, my exponent ended up not being a fraction. So that's one way you guys can simplify the radical before. I want to show you the other way, where you can simplify the fractional exponent at the end as well. I just like doing the radical because it's a little bit more simple than dealing with fractions. So if I were to write, we had the square root of 3x to the 4th power. So if I was automatically to write this into my exponential form, I would have 4 over 2. Well, we have to divide that fraction, so 4 divided by 2, we get 3x, and make sure you have it in parentheses because that's how the radicand originally, the problem originally was. So now I have 3x squared. You need to still simplify this. Remember, our exponents are 1 here, so now they get distributed and multiplied. So now I have 3 squared and x squared. Well, if I were to simplify that, 3 squared was 9, and we get x squared to leave the same. So we get the same answer, just a different way. I don't know which way you guys like better. It's up to you to continue on whichever method that you feel better about. Okay, and then there was only 2 problems that I wanted you guys to complete on this one. Again, pause the video, try and complete it. So you're going to go from the radical form to the exponential form. So this is the cubed root of s to the 2nd power, and then we have 12 cubed root x to the 2nd power. Okay, so please go ahead and finish those problems, practice those on your own, and we will go over a couple of these in class. See you then.